Alright, so in this chapter 10, we're going to be talking about, let's see if I can make that a little more clear. Chapter 10 is about k-nearest neighbors. And so we're going to see that this can be used, k-nearest neighbors can be used as a classifier and to do regression. That means build functions from data. Okay, so we're going to be doing both, doing some classifications and doing some regression. Now, I should say that the real reason that we're doing this now is that I want to highlight things to do with data. So when you're given data, highlight techniques to deal with data and training parameters just in general, right? So if we're building any kind of classifier or any kind of regression, there's going to be some techniques that we're going to use often for every case. Okay, and so that's what we want to talk about today. Good. So to begin with, there's a kind of a basic observation at the heart of the nearest neighbor classifier, and that is the way we typically do predictions in our real life is we think about when things are very similar to things that have happened in the past, and we predict based on that. So the closer something is, the circumstances are to something that happened in the past, something that happened in our experience, then we can hopefully build some kind of a predictor off of that. If we are getting like novel situations or novel experience, then there's really no way that we can predict what's going to happen, right? So we try to do the best we can, but since it's outside of our experience, it's a lot harder to do. And so the nearest neighbors works off this property, right? That the way to predict on new data is we'll look to see what happened in the past with our previous data, and we'll just predict based on that. Okay, so what does the algorithm do? So we'll talk about the classifier first, the k-nearest neighbor classifier. Or actually, in this case, it's just the nearest neighbor classifier. We're going to be given p points in Rn, and with those p points, we'll have a target vector. Let's make this matrix X. So let's see, which size should we make that? I think to be consistent, we'll take the n by p. So p is the number of points, right? And then our vector of class labels we'll make as our target vector t, and so that'll be p by 1 or 1 by p. Doesn't really matter for that since it's a vector. Okay, and now the question is, given x hat, which is a new data point, what should I label it as, or what should its label be? Maybe I'll do it that way. Well, in 2 dimensions, right, we just have a bunch of data here with class labels. So this might be label A, this might be B, 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 B. And then I'm giving you a new data point, let's call it x hat here. I'm saying, what should the label of x hat be? Alright, so by the name, of course, you know how we're going to do this. We're just going to, for the nearest neighbor classifier, we're just going to look for the point. So look for the point in the matrix X that's closest to X hat and use its label for the new point. Easy. Good. That is the nearest neighbor classifier. So a couple of points, because we've talked about classifiers before, or data cluster. This is really kind of a clustering algorithm, right? And so in this let me rephrase that. I want to say that with labels, our clustering algorithm becomes supervised. And rather than doing data clustering, we're actually doing classification. And instead of clustering, we perform classification. And of course the classes, right, are the cluster memberships. And so this is a supervised, so before, remember, we had an unsupervised learning task. Now it's interesting to think about what kind of sets this nearest neighbor algorithm actually produces, right? Because maybe I should draw this a little bit bigger. Suppose I've just got a few of my training points here. Right, this is class A, class A, class B, class B. Question is, what do the boundaries look like here? Well, as it turns out, the boundaries are going to look like Voronoi cells with the one nearest neighbor. So the boundaries here form boundaries in one nearest neighbor classification form Voronoi cells. So it's the appearance of the Voronoi cell again. Good. Alright, so we're going to take a look to see what this looks like more globally. So when we're focusing in on just a few data points like this, it looks like the boundaries are really nice. But actually when you when you have a lot of data, the one nearest neighbor algorithm doesn't work very well because it's too complicated. It's more like memorizing the data instead of generalizing. Okay, but let's see. I think we'll go ahead and do a quick little program here. Because the nearest neighbor algorithm, or the classifier, is so easy, we can just write it straight down. So what's the first thing I do? So I'm given a matrix X and my target's T, right? That was n by p, I think, right? And p by 1. And we're also given X hat. Find the label for X hat. So how am I going to do that? So MATLAB is pretty easy to do here, because what you do is you can just take, for example, temp, and you can subtract X hat from all of the columns of X, and that's actually really easy to do, right? Because if you have a matrix minus a column vector, it automatically assumes that you want to subtract that from each column of the matrix X. And then how do we get our distances from that? Well, you can just square this or multiply it by itself. Okay, so this is just squaring each of the elements, I should say, of the matrix temp. Now what are we going to do with that? I didn't leave myself enough room here. Because what I want to do with the squares is I want to sum, gosh darn it, I want to sum down, right? so that I have a vector that's p by 1 of distances. Okay, so I'm just going to be summing. Oh gosh, you can't see that. Sorry about that. Let's take a sum of temp star, let's call that distances. Good. Alright. We're basically done. Now that we have our distances, we just have to find the shortest one. And so in MATLAB, the sort command outputs two different things. The first thing are the values of the sorted vector, and the second thing are the indices of the sorted data. So for example, if the first data point here was a 2, that would mean the second element of the vector is the smallest. Okay, so that's the index of the sorted data. Then we would sort distances. Good. And then what did we say our class label was? Class label is equal to the first the index, the first index here. We actually read it off of our targets, right? So we take our target, and then I look at my IDX vector, and I look at the first element of that. Okay, and so this is the index, the column index, I should say, column index of X with the smallest distance. Good, and we're done. That's it. That is your one nearest neighbor classifier. Good. So you can see that this is very short in Python as well, probably, right? Python. So I'm going to try to use it more now. So we have to have the NumPy, so we'll import NumPy as NP. And then we'll basically be doing the same thing. So I'm going to be assuming here that I've got X and T and X hat. And so my temp matrix is just going to be my X minus, what am I calling it now? I guess X hat or hat, whatever. I'll use the hat there. Okay. And so now we just take distances again is equal to, now you have to do np.sum, right? Instead of just sum. And then you can take temp squared. Let's see. I better be careful here. Hang on one sec. Okay, I just forgot to square my temp here. So we have to have an np dot square. We have to spell it out, yeah. And then temp. Good. But then we have to say which axis we want to sum over, and so axis equals 0, we'll do the sum, like we were saying before, the sum down, and that should get us a distances here should be a 1 by p row. Then of course we just do the same thing we did before, that we get the index. So the index for the sort is arg sort, argument of the sort, and then we take our distances. Then of course the class label will be the first one of those. So that would be T square bracket IDX square bracket 0. Good. Oop, I don't need that semicolon, do I? Jumping back and forth between languages is hard to do. Okay, good. There we go. That is the nearest neighbor algorithm. The one nearest neighbor algorithm. So in the next video we'll talk about extending that. See you then.